Today we are going to discuss Fourier series. So, if any periodic function, let us consider any periodic function, if we express in terms of sine, comma, cosine terms, then that is called a Fourier series. That is called a Fourier series. Okay, this is the first one. So any periodic function, if you can express in terms of sine and cos, you can call it as a Fourier series. So next one, what is meant by periodic function? We will discuss. So periodic function. So the periodic function examples let us consider. So sine x, comma cos x. These are the periodic functions with a period 2 pi. Similarly, tan x, comma cot x are the periodic functions with a period pi. So what this meaning is 2 pi means with after period 2 pi, so you are going to get the same figure. Here also after the period pi, you are the figure going to be repeated. So therefore the period is pi. Here the period is 2 pi. Okay. So next one. So Fourier series f of x, a function f of x, Fourier series of a function f of x can be written as a naught by 2 plus sigma n is equal to 1 to infinity a n cos nx plus sigma n is equal to 1 to infinity b n sin nx. Okay. So this is about the Fourier series expansion of a function f of x. Okay. So here we are going to discuss about the period 2l. Okay, period 2l. So period 2 pi, not 2l. So we are going to discuss period 2 pi. Okay. So minus pi to pi, minus pi to pi means period 2 pi. Similarly, period 0 to 2 pi, that means this is also having the period 2 pi. So how to find out the a naught value if the interval is minus pi to pi? So okay, what is the formula means 1 by pi integral minus pi to pi f of x dx. Okay. So here what that one means, a naught is equal to 1 by pi integral 0 to 2 pi. So here it is 0 to 2 pi, that's why I am writing 0 to 2 pi. Here it is minus pi to pi, I am writing minus pi to pi. So a naught is equal to 1 by pi integral 0 to 2 pi f of x dx here. Similarly, a n value for the interval minus pi to pi, a n is equal to 1 by pi integral minus pi to pi f of x into cos nx dx. Okay. Similarly, here a n is equal to 1 by pi integral 0 to 2 pi f of x into cos nx dx. Okay. Similarly, bn is equal to 1 by pi integral minus pi to pi f of x into sin nx dx. Here bn is equal to 1 by pi integral 0 to 2 pi f of x sin nx dx. Okay. So first one what we have discussed is the Fourier series. So any periodic function in terms of sine and cosine terms is called as Fourier series. Next one, so what is meant by periodic function and the examples of the periodic function. So this is the Fourier series representation. So if you consider the period 2 pi, so minus pi to pi is also having the period 2 pi. So here also 0 to 2 pi means you are having the period 2 pi. So for that one a naught values minus pi to pi, so and so a n is equal to this one, bn is equal to this one, 0 to 2 pi, a0 is this one, an is this one, bn is this one. So only the difference between these two is, so the limits here, it is, if it is 0 to 2 pi we have to write 0 to 2 pi, here it is minus pi 2 means we have to write minus pi 2 pi. That is the main difference. Okay, so next one we require some important formulas to solve the Fourier series problems. So we will discuss one by one. Okay, the first formula you have to remember is sin n pi. Sin n pi is equal to 0. Next one, sin 2n pi is equal to 0. Next one, cos n pi is equal to minus 1 whole power n. Similarly, cos 2n pi is equal to 0. Cos 2n pi is equal to 0. Similarly, we require some transformation formulas. So 2 sin A sin B. 2 sin A sin B is equal to cos A minus B minus cos A plus B. Similarly, 2 cos A cos B. 2 cos A cos B. That is cos A plus B plus cos A minus B. Similarly, we require 2 sin A cos B. 2 sin A cos B means sin A plus B plus sin A minus B. Sin A minus B. Similarly, we require 2 cos A sin B. 2 cos A sin B is equal to sin A plus B minus sin A minus B. So these are the transformation formulas we require. Similarly, we require two formulas: integration, integral e power ax into sin bx, integral e power ax into sin bx dx is equal to e power ax by a square plus b square into a sin bx minus b cos bx. Okay. Similarly, we require one more formula: integral e power ax into cos bx dx is equal to e power ax by a square plus b square into a cos bx plus b sin bx, a cos bx plus b sin bx. So these are the important formulas. So with that one we can solve the Fourier series problems. Okay, now we are going to look at the Fourier applications. Okay, first we will discuss this is the sine wave. This is the sine wave. Okay, next we will consider the cosine wave. This is the cosine wave. Okay, and now if we consider triangle. So as the number of terms increases, if you look at that one, you will get the absolute fine figure. Okay, the number of terms increases, you will get the absolute figure. Okay, if you, the number of terms decreases, what happens? Just look at that one. Okay, that is the way. So if you consider sawtooth wave, and if the number of terms increases, go on increases, so you'll get a sharp fine figure. Okay, so look at that one, look at that one. Okay, you are going to get a fine sharp figure. So similarly, if the number of terms decreases, if you look at that figure, so this is the way. Okay, so next one you consider a rectangular wave. So if the number of terms increases, what happens? Just look at that one. So this is the absolute fine figure you are going to get. Okay, next one, if you consider another one, noise wave. So if the number of terms increases, go on increases, so we'll get a fine sharp figure. So this is about the Fourier series. Okay, today we are going to discuss Fourier series. Fourier series. Okay, Fourier series. So first we will discuss one problem, that is expand f of x is equal to x minus pi. F of x is equal to x minus pi. You have to expand f of x is equal to x minus pi as Fourier series. Fourier series means nothing but summation of the terms sine and cosine terms. Okay, so in the interval minus pi less than x less than pi. Okay, so first step. So Fourier series, what it says is the function you can express it as a naught by 2 plus sigma n is equal to 1 to infinity a n cos nx plus sigma n is equal to 1 to infinity bn sin nx. Okay, this is the first step. Next we will go for the second step. Second step means a naught value is equal to 1 by pi integral, so minus pi to pi f of x dx. Okay, that is equal to 1 by pi integral minus pi to pi f of x is nothing but x minus pi into dx. So this you can write it as 1 by pi into integral of x minus pi. Integral of x is how much? So we will write it as integral minus pi to pi x dx minus pi into integral minus pi to pi 1 dx. Okay, so this is nothing but equal to, here integral minus pi to pi x dx, x is an odd function integral minus pi to pi, therefore it is the value is 0, therefore 1 by pi into 0 minus pi into integral of 1 dx means x between the limits minus pi to pi, so that is nothing but 1 by pi into minus pi into pi minus plus pi, that is equal to how much you are going to get, pi will get cancelled. Okay, we left with minus pi minus 2 pi, you are going to get minus 2 pi. This is the a naught value. Next we are going to have to find out a n value. A n is equal to 1 by pi formula integral minus pi to pi f of x into cos nx dx, f of x into cos nx dx, that is equal to 1 by pi into integral minus pi to pi f of x is nothing but x minus pi into cos nx dx. Okay, this is nothing but, this you can write it as 1 by pi into this is you can write it as 1 by pi into, okay, integral minus pi to pi x cos nx dx minus pi into integral minus pi to pi cos nx dx. Okay, this is nothing but equal to 1 by pi into x is which function? Odd function. This is an even function. Odd into even, again odd function. Odd function between the limits minus pi to pi, you are going to get 0 minus pi into integral of this cos n x. Integral of cos n x is how much? Sin n x. Sin n x by n between the limits minus pi to pi. Okay, so this is nothing but equal to 1 by pi, 1 by pi, and this pi, these two will get cancelled. So what we left with is minus into, if you substitute upper limit pi, if you substitute the upper limit pi, you are going to get sin n pi by n minus sin n of minus pi by n. So how much? Anyway, sin n pi or sin n into minus pi, both are 0. Therefore a n term you are going to get 0. A n term you are going to get 0. Similarly we have to get the bn value. Okay, bn value. So bn formula is what? Bn is equal to 1 by pi integral minus pi to pi f of x into sin nx dx, that is equal to 1 by pi into integral minus pi to pi, f of x value is x minus pi into sin nx dx, that is equal to 1 by pi into integral minus pi to pi x sin nx dx minus pi into integral minus pi to pi sin nx dx. So that is nothing but equal to 1 by pi into x is an odd function, sin is an odd function, odd into odd an even function. Even function between the limits minus pi to pi, you can write it as 2 integral 0 to pi x sin nx dx minus sin nx is which function? Odd function. Odd function minus pi to pi means you will get integration is 0. Therefore that is equal to 2 by pi into integral of x sin x. X sin x means x into integration of this one. Integration of sin nx means you are going to get minus cos nx by n minus x differentiation is 1 into again integration of this one minus sin nx by n square between the limits 0 to pi. So now you substitute the limits 2 by pi into 2 by pi into pi minus pi into cos n pi by n. So minus into minus plus, this minus into minus plus sin n pi by n square. So after limit is over, now you subtract minus, so minus minus 0 into something means 0. Next one, if you substitute the lower limit in this one, you are going to get again 0. Therefore you left with like this. Therefore that is nothing but here 2 by pi into minus pi into cos n pi is equal to minus 1 power n plus sin n pi means 0. So whole by n. Okay, so that is nothing but pi will get cancelled. So 2 into minus 1 power n plus 1 by n you are going to get 2 into minus 1 power n plus 1 by n. So this is the bn value. So bn value. So finally you substitute all the values in f of x. So a naught value, you got some value. A naught is equal to how much you have, you got that value. A naught is equal to minus 2 pi. A naught is equal to minus 2 pi. So similarly an is equal to, you got some value, that is 0, 0. Similarly bn value is equal to 2 into minus 1 power n plus 1 by n. So substitute all the values in f of x, you will get the Fourier series. Okay, thank you very much. Today we are going to solve one more problem on Fourier series. So what is that problem is f of x is equal to x cos x, x into cos x, x lies between 0 to 2 pi. Okay, x lies between 0 to 2 pi. So we have to express f of x is equal to x cos x as a Fourier series. So the first step we have, it is f of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n cos nx plus sigma n is equal to 1 to infinity bn sin nx. Okay, second step, where a naught is equal to, formula is what, 1 by pi integral 0 to 2 pi f of x dx. Okay, so that is nothing but 1 by pi into integral 0 to 2 pi f of x is how much, x cos x, x cos x dx, x cos x into dx. So integration of x cos x, how you can do, 1 by pi into x into cos x integration. Cos x integration is sin x minus x differentiation 1 into sin x integration minus cos x between the limits 0 to 2 pi. So that is equal to 1 by pi into, so if you substitute in place of x 2 pi and in place of x 2 pi, you are going to get 0. Therefore 0 minus, if you substitute 2 pi here in this place, so minus into minus plus, minus into minus plus, cos 2 pi, cos 2 pi is equal to how much, 1. Cos 2 pi is equal to 1. So now what you did is, upper limit you have substituted, now you have to substitute the lower limit. So 0, this 0 you substitute here in x, 0 into something 0, minus into minus plus, minus into minus plus, cos 0, cos 0 is how much, 1. Okay, so if you simplify this one, 1 minus 1, 0 into something, so a naught value you are going to get 0, a naught value you are going to get 0. Next, which value you have to find out, you have to find out an. An is equal to, what is the formula, 1 by pi integral 0 to 2 pi f of x into cos nx dx, f of x into cos nx dx, that is equal to 1 by pi into integral 0 to 2 pi, in place of f of x how much you have to write, x cos x, x cos x into cos nx dx, cos nx dx. So this you can again rewrite it as 1 by 2 pi, so I am dividing with 2, so integral 0 to 2 pi x into, I am writing it as 2 cos x cos nx dx. Okay, so what we did is, I have multiplied with 2 and divided with 2 for our convenience, that is equal to 1 by 2 pi into, okay, 1 by 2 pi into integral 0 to 2 pi x into, okay, this is 2 cos a cos b, 2 cos a cos b. So what is the formula? Cos a plus b, cos a plus b, 1 plus n into x plus cos a minus b, cos a minus b, cos 1 minus n into x. So bit dx, okay, that is equal to 1 by 2 pi into integral of x into something. So x into integration of this one, integration of entire one. Integration of entire one means integration of entire one. So cos integration is sin 1 plus n into x by 1 plus n plus sin 1 minus n into x by 1 minus x. Okay, so x into this one minus x differentiation is 1, 1 into again integration of this one, sin integration is minus cos 1 plus n into x by 1 plus n whole square plus sin integration is again minus cos 1 minus n into x by 1 minus n whole square, 1 minus n whole square between the limits 0 to 2 pi. So if you substitute the values in this one, so how much you are going to get is nothing but, so an is equal to 1 by 2 pi into, how much you are going to get is 1 by 2 pi into cos of 1 plus n into x by 1 plus n whole square plus cos of 1 minus n into x by 1 minus n whole square between the limits 0 to 2 pi, 0 to 2 pi. So if you do the simplification, you are going to get this as 0, this as 0. So an is equal to, you will get 0. Similarly, you have to get the value of bn. Bn is equal to, bn is equal to, formula is 1 by pi integral 0 to 2 pi f of x into sin nx dx, that is equal to 1 by pi integral 0 to 2 pi f of x means x cos x sin nx dx. This you can write as 1 by 2 pi into integral 0 to 2 pi into x into 2 cos x into sin nx dx. Okay, sin nx into dx. So that is nothing but 1 by 2 pi into 1 by 2 pi into, so integration of this one means x into, so integration of 2 cos x into sin x means, so in not integration, integral 0 to 2 pi into x into, this is 2 cos a sin b, 2 cos a sin b, 2 cos a sin b means sin a plus b minus sin a minus b, sin a plus b minus sin a minus b. Okay, sin a plus b into sin a minus b into dx. So that is equal to 1 by 2 pi into, so now integration of x into this much, x into this much means x into integration of that one means sin integration minus cos 1 plus n into x by 1 plus n minus, again sin integration is minus cos, therefore plus cos 1 minus n into x by 1 minus n. Okay, minus x differentiation is 1 into again integration of this much, integration of that much is minus cos integration is sine 1 plus n into x by 1 plus n whole square, my plus cos integration is sine 1 minus n into x by 1 minus n whole square between the limits 0 to 2 pi, 0 to 2 pi. So if you do the substitution, how much you are going to get is 1 by 2 pi into 1 by 2 pi into, so 2 pi into, you substitute the values here, so minus cos 1 plus n into 2 pi, so and that means 2n pi, 2n pi. So how much you are going to get, it is the value is 1 minus 1 by 1 plus n plus 2 pi. So 1 minus n into 2 pi, 1 minus n into 2 pi means 1 by 1 minus n, 1 by 1 minus n, 1 by 1 minus n minus, if you substitute 0, 2 pi here, if you substitute the upper limit here, here it is 0, here it is 0, so 0 plus 0 let us consider. So up to now the upper limit is substitution is over, now you have to go for the lower limit, minus of, so 0 into something, so you will get 0 minus, here also 0, here also 0, so 0 plus 0 let us consider. So what you are going to left with is 1 by 2 pi, 2 pi, these two will get cancelled, so what you left with is 1 by 1 minus n, 1 by 1 minus n minus 1 by 1 plus n, so that is nothing but how much you are going to left with is 1 plus n minus 1 plus n by 1 minus n square, so that is nothing but 2n by 1 minus n square. So this is the bn value. So in the previous step we got the a naught value as 0, a naught value as 0, so in the next one an is also 0, an value is also 0, an value is also 0. So similarly bn value you got it as, bn value you got it as 2n by n square. So substitute all these values a naught, an, bn in the first step, that is this one, you are going to get the Fourier series expansion. Okay, thank you. Today we are going to discuss some problems in Fourier series having points of discontinuity, having points of discontinuity. So points of discontinuity. So first we will discuss one problem. So what is that one is, expand f of x is equal to, f of x is equal to 1, 0 less than x less than pi, and 0 pi less than x less than 2 pi. You have to expand it as a Fourier series. As a Fourier series we have to expand. Okay, so first step is what, f of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n cos nx plus sigma n is equal to 1 to infinity b n sin nx. Okay, what is the formula for a naught? A naught is equal to 1 by pi integral 0 to, starting with 0 and with 2 pi. So this is the main problem what he has given. Okay, so 1 by pi integral 0 to 2 pi f of x dx, f of x dx. But this integral you can split into sum of the two integrals as 1 by pi into integral 0 to pi f of x dx plus integral pi to 2 pi f of x dx. Okay, so again this you can write as 1 by pi into, if for integral 0 to pi, what is the f of x value? 1. So 1 dx plus for integral pi to 2 pi, what is the f of x value? It is 0. 0 into dx. Okay, so that is nothing but 1 by pi into integral 0 to pi 1 dx. So integration of 1 is x. X between the limits 0 to pi. So that is equal to pi into pi minus 0, sorry, 1 by pi into pi minus 0, you will get it. So pi divided by pi, so you left with 1. So a naught value is equal to, you got it as 1. So next one, an formula. An is equal to, what is the formula? 1 by pi integral 0 to 2 pi again f of x into cos nx dx. So that is equal to 1 by pi into this integral 0 to 2 pi, you can write it as sum of the two integrals. Integral 0 to pi f of x cos nx dx plus integral pi to 2 pi f of x cos nx dx, cos nx dx. That is equal to 1 by pi into integral 0 to pi, f of x value is how much? 1 for integral 0 to pi, therefore cos nx dx we left with. So here integral pi to 2 pi f of x dx means, for integral pi to 2 pi f of x value is how much? F of x value is 0. So 0 into cos nx dx. So this is nothing but 1 by pi into in, so anyway this will vanish in 0 into something, integral 0 to pi into cos nx integration. Cos nx integration is sin nx by n between the limits 0 to pi. So that is equal to 1 by pi into 1 by n pi, 1 by n pi into 1 by n pi into, now you substitute pi upper limit, sin n pi 0 minus sin 0 0. So a n value how much you are going to get it as? A n is equal to 0, you are going to get. So a n is equal to 0, a naught is equal to 1, a naught is equal to 1, a n is equal to 0. Okay, next we are going to find out the value of bn. So bn is equal to, what is the formula? Bn is equal to 1 by pi integral 0 to 2 pi f of x into sin nx dx. That is equal to 1 by pi into this integral you can write as 0 to pi f of x into sin nx dx plus integral pi to 2 pi f of x into sin nx dx. Okay, for integral 0 to pi, what is the function value? Is 1. Therefore integral 0 to pi sin nx dx we left with, plus integral pi to 2 pi, what is the function value? 0. Therefore integral pi to 2 pi into, here 0 into sin nx dx we left with. Therefore this value enter 1 is 0. So that is nothing but 1 by pi into, so integration of sin nx is minus cos nx by n between the limits 0 to pi. So that is equal to 1 by pi into minus 1 by pi into cos minus 1 by n pi into cos n pi minus cos 0. So that is equal to minus 1 by n pi into cos n pi is equal to minus 1 whole power n minus 1 minus 1. So this you can write as 1 by n pi into 1 minus 1 whole power n, 1 minus 1 whole power n. So this is the a bn value, this is the bn value. So bn is equal to, so if you substitute, if n is even, n is even, let us consider if n is even, so what happens, let us consider n is equal to 2. So what happens here, it is plus 1, 1 minus 1 0, therefore n is even, bn value is 0. So if n is odd, n is odd, if n is odd, what happens, n is odd, minus 1 whole power 1, that means 1 plus 1, 2, 2 by n pi, 2 by n pi, you are going to get 2 by n pi. So bn is equal to 0 when n is even, bn is equal to 2 by n pi when n is odd. So all the values you substitute in f of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n cos nx plus sigma n is equal to 1 to infinity bn sin nx. Okay, you will get the Fourier series expansion. Okay, thank you. Today we are going to discuss even and odd functions. Today we are going to discuss even and odd functions. Okay, so what is meant by even function? So if f of minus x is equal to f of x, then you call it as even function. So what is meant by an odd function? Odd function means f of minus x is equal to minus f of x, then you call it as an odd function. Okay, so let us consider one example. Okay, so example, so if you consider x square, similarly x power 4, similarly cos x, all are the examples of even functions, examples of even functions. Similarly odd function examples, we consider x comma x cube comma sin x, these are all the examples of odd functions. Okay, next again if you consider, let us consider some properties. So an even function plus an even function, the summation is an even function. Similarly if you consider an odd function plus again an odd function, the summation should be a odd function. This always you have to remember. Okay, next one again, if you consider one more property, so that is, so product, so even function into an even function is again an even function. So here also even function, sorry, product means odd, so that is nothing but so an odd function into an odd function, this product is nothing but an even function. So odd into odd is nothing but an even function. Similarly next we will consider one more example. So an even function into an odd function, even function into an odd function, you are going to get an odd function. Here also an odd function into an even function, you are going to get an odd function. Okay, so we have some related to the integration, we have some results. Let us look at that one also. So even function, So if the integration is between the limits minus a to a f of x dx, okay, then you can write it as 2 integral 0 to a f of x dx. When you can write this one, if f of x is even function only. So similarly, integral minus a to a f of x dx. So if this f of x is an odd function, the value is 0. The value is 0. So this is about the introduction to the even functions and odd functions. So what is meant by an even function means if f of minus x is equal to f of x, then you call it as even function. Examples. So in place of x, if you substitute minus x whole square in this one, you will get same x square. So in place of x if you substitute minus x whole power 4, same x power 4 you will get. Cos of minus x cos x. Therefore, these are all even functions. So an even function plus in even function, again you are going to get an even function. So product of two even functions we have discussed, that is also an even function. An even function and into an odd function, you are going to get an odd function. Similarly, integral minus a to a f of x dx is nothing but 2 integral a 0 to a f of x dx if f of x is an even function. Similarly, odd function, f of minus x is equal to minus f of x, then you call it as a odd function. Examples: x comma x cube sin x. So if you substitute in place of x minus x, you are going to get minus x. So minus x whole cube, you will get minus x cube. Sin of minus x is minus sin x. Therefore, these are all the odd functions. Odd function plus an odd function. Summation of two odd functions is again odd function. Product of two odd functions is an even function. So product of odd and even functions is odd function, and integration minus a to a f of x dx. If the f of x is an odd function, the value you are going to get is 0. Okay. So now we look at the some examples of even functions and odd functions. Even functions and odd functions. Suppose if you consider f of x is equal to mod x, f of x is equal to mod x. This is the graph of f of x is equal to mod x. So if you consider an even function, so if you consider this right hand side part, if you consider this right hand side part, this is symmetrical about the this y-axis. The same figure what you have on the right hand side, the same figure you have on the left hand side. That you have to always remember. So if f of x is equal to x square, if you consider the same line what is on the right hand side, the same line is here on the left hand side. Okay, if it is like that, then you can say that it is an even function. So suppose if you consider here an odd function, f of x is equal to 1 by x. Okay, so this is the line on the right hand side. The same line has been there on the left hand side. Okay, so but upside down. Okay, the same line is there on the left hand side, but it is upside down. Similarly here, if you consider this figure, f of x is equal to x cube. So whatever the line on the right hand side, that is upside down on the left hand side, then it is an odd function. So generally how geometrically you can remember means, for even functions, whatever the line on the right hand side, the same will be on the left hand side. If you consider this picture also, whatever the line on the left hand side, right hand side, the same will be on the left hand side. Suppose if you consider this one, so whatever the line here on the right hand side, that will be upside down on the left hand side. Okay, similarly here also. Okay, this is about the even function and odd functions. So geometrically how you can vary the functions. Okay, today we are going to discuss half range Fourier series. So what is meant by half range Fourier series? First we will discuss what is meant by half range Fourier series. So here previously we did the problems on Fourier series in the interval 0 to 2 pi, minus pi to pi. Okay, 0 to 2 pi minus pi to pi. So its period is 2 pi. Now we are going to discuss the problems in the interval 0 to pi. Sometimes you require to solve the problems in the interval 0 to pi. So those problems are called the half range Fourier series. So here the period is 2 pi. Here the period is pi. So half of the 2 pi. Therefore it is called as the half range Fourier series. Okay, this half range Fourier series has been, you come across with the sine series and cosine series. Sine series and cosine series. So you have to remember only few points concerned about sine series and cosine series. So in cosine series, you the terms exist will be a naught and an. So these two terms will exist and the bn term will be 0. Okay, in the sine series a naught is equal to 0 and an is equal to 0, only bn term will exist. Bn term will exist. So this is the basic concept regarding the half range sine series and half range cosine series. So here what is the formula for a naught for cosine series means, so only simple change in the previous formula what you have learned. There you come across with a naught is equal to 1 by pi into something. Here you have to write 2 by pi into integral integral 0 to pi f of x into dx. Okay, so here an is equal to 2 by pi into integral 0 to pi into f of x cos nx dx. Okay, here also bn. So for the bn, what the formula means, 2 by pi into integral 0 to pi into f of x sin nx dx. So this is the formula. So this is the bn formula. So you have to remember these formulas. So basic difference between the previous formulas and this one is nothing but, there you come across with the 1 by pi, here you come across with the 2 by pi. Okay, 2 by pi. So you just remember these formulas, you can solve the problems very easily in half range Fourier series. So first we will discuss one problem. So that is equal to f of x is equal to cos x in the interval 0 to pi. Okay, f of x is equal to cos x. So first problem, f of x is equal to, sorry, x not cos x, f of x is equal to x. So the interval is 0 to pi. So find, first question, half range sine series, half range sine series comma cosine series, cosine series. So first we will discuss sine series. Let us consider sine series. So half range for sine series, what the term will exist, bn term only exist. That means a naught is equal to 0 and an is equal to 0, an is equal to 0. So what you left with is bn is equal to term only exist, bn is equal to 2 by pi integral 0 to pi f of x sin nx dx. Okay, 2 by pi integral 0 to pi f of x sin nx dx. So bn is equal to, we have to find out the value. Bn is equal to 2 by pi integral 0 to pi f of x is how much? X, x sin nx dx, that is equal to 2 by pi into, so integration of x sin nx, x into sin nx integration minus cos nx by n minus x differentiation is 1 into again cos nx integration, so sin nx by n square between the limits 0 to pi, so that is nothing but equal to 2 by pi into, okay, so minus pi cos n pi minus pi cos n pi by n minus into minus plus sin n pi by n square minus, so this term will be 0. If you substitute in sin nx, you are going to get this term also 0. So that is nothing but equal to 2 by pi into minus pi into cos n pi means minus 1 whole power n by n plus sin n pi means 0. So you left with this term only. The pi will get cancelled. So you left with 2 into minus 2 into minus 1 power n by n. So this is nothing but 2 into minus 1 whole power n plus 1 by n minus 1 whole power n plus 1 by n. Okay, so then what is the half range sine series? So f of x is equal to a naught a n is equal to 0, therefore a naught by 2 plus sigma n is equal to 1 to infinity a n cos nx plus sigma n is equal to 1 to infinity bn sin nx. So that is nothing but that is equal to a naught by 2, so 0, a n also 0, therefore you left with the only term bn. So bn is equal to how much? 2 into minus 1 whole power n plus 1 by n, bn term, into sin nx. So this term we left with, this is the Fourier series, half range Fourier series. Okay, similarly we have to find out half range cosine series. Okay, for the same problem f of x is equal to x, we have to find out the half range cosine series. So in cosine series, a naught is equal to, what is the formula? 2 by pi into integral 0 to pi f of x dx. An formula is equal to what? An is equal to 2 by pi integral 0 to pi f of x into cos nx dx. So for cosine series, bn is equal to 0. Okay, so second step, a naught is equal to 2 by pi into integral 0 to pi f of x is x dx, that is nothing but 2 by pi into x square by 2 between the limits 0 to pi, that is equal to 2 by pi into pi square by 2. So pi left with 1 pi in the numerator, that is equal to pi is the a naught value. So an is equal to 2 by pi into integral 0 to pi f of x is x cos nx dx. Okay, that is equal to 2 by pi into x cos nx integration x into sin nx by n, sin nx by n minus x differentiation is 1 and sin nx integration is minus cos nx by n square between the limit 0 to pi. So that is nothing but equal to 2 by pi into, if you substitute pi, so pi sin n pi by n minus into minus plus cos n pi by n square minus 0 into something is 0, so minus into minus plus, so cos 0 means 1 by n square. Okay, this you left with, that is equal to 2 by pi into sin n pi is equal to 0, first term will vanish, cos n pi is equal to minus 1 power n by n square minus into plus minus 1 by n square. So what you left with is 2 by n square pi into minus 1 whole power n minus 1, 2 by n square pi into minus 1 whole power n minus 1. So an is equal to, if n is even, let us consider, if n is even, so minus 1 power 2 means plus 1, 1 minus 1 0 into something 0, an is equal to 0. So if n is odd, what happens? If n is odd, if n is odd, what happens? An is equal to, let us consider n is equal to 3, minus 1 whole power 3 minus 1 minus 1 minus 1 minus 2 into plus 2 minus 4 by n square pi. An is equal to, so if n is even, an is equal to 0, if n is odd, minus 4 by n square pi. So therefore Fourier series f of x is equal to a naught by 2, a naught is equal to pi, pi by 2 plus sigma, an values exist for n is odd only, therefore you consider n is equal to 1 3 5 so on up to infinity. So mine an value minus 4 by n square pi into cos nx. Okay, so this is the Fourier cosine series for the function f of x is equal to x. So with that one, so this is the basic small problem in the half range Fourier series. Okay, today we are going to learn the functions having the period 2l. Okay, so first we will have the introduction. So for Fourier series, f of x is equal to, what is the formula? A naught by 2 plus sigma n is equal to 1 to infinity a n. Here the formula is somewhat different, that is cos n pi x by l plus sigma n is equal to 1 to infinity bn sin n pi x by l. So the Fourier expansion f of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n cos n pi x by l, similarly bn sin n pi x by l. Okay, where a naught is equal to, a naught is equal to 1 by l integral. So according to the limits, if it is minus l to l, you write minus l to l. So if it is 0 to 2l, you write 0 to 2l. Okay, so let us consider minus l to l. So 1 by l minus l to l f of x dx. Okay, a naught value a n is equal to 1 by l integral minus l to l f of x into cos n pi x by l dx. Okay, similarly bn is equal to 1 by l integral minus l to l f of x into sin n pi x by l, sin n pi x by l dx. So a naught. So this is the first one is the Fourier series expansion. F of x is equal to this much. Okay, where a naught is equal to this one formula, a n is equal to this one formula, b n is equal to this one is the formula. When if this is the interval he has given minus l to l. Okay, now we consider one problem. F of x is equal to x square. Okay, f of x is equal to x square in the interval minus l to plus l, minus l to plus l, minus l to plus l. So first we have to find out a naught. A naught is equal to what is the formula? 1 by l integral minus l to l f of x dx. Okay, this is the formula that is equal to, so 1 by l integral minus l to l f of x means x square dx. Okay, x square dx. So x square is which type of function? Even function. X square is even function. X even function between the limits minus l to l, between the limits minus l to l. That means how we can write that one as 2 by l integral 0 to l x square dx. Okay, that is equal to 2 by l into x cube by 3 between the limits 0 to l, that is nothing but 2l cube by l, that is equal to 2 by 3 l square. A naught value is 2 by 3 l square. Similarly you have to find out an. An is equal to what is the formula? 1 by l integral minus l to plus l f of x into cos n pi x by l into dx. Okay, that is equal to 1 by l integral minus l to l f of x is x square, x square cos n pi x by l dx, cos n pi x by l dx. So now 1 by x square is which type of function? Even function. Cos n pi x by l is also even. Even into even. Even into even is even. Therefore this integration you can write as 2 by l into integral 0 to l into x square cos n pi x by l into dx. So that is equal to 2 by l into x square into, okay, cos n pi x by l integration sin n pi x by l by n pi by l. Okay, cos n pi x sin n pi x by l by n pi by l minus x square differentiation 2x. So this integration is nothing but minus cos n pi x by l by n square pi square by l square. Next 2x differentiation 2 into, so cos n pi x l integration is sin n pi x by l by n cube pi cube by l cube. So the limits are between the 0 to l. So that is nothing but 2 by l into, first we substitute the upper limit. If you substitute the upper limit, L square into sin n pi L by L. That means sin n pi numerator. Sin n pi by L. Okay. Minus 2L. So minus this minus into this minus is you are going to get plus. Therefore plus 2L into cos n pi x by L. So n pi L by L. N pi L by L means you will get cos n pi. Cos n pi by n square pi square by L square. So next one plus 2 into minus. So you left with minus 2 into sin n pi L by L. That means sin n pi by n cube pi cube by L cube. So this is about the upper limit. Now you substitute the lower limit. So 0 into something. 0 into something. Therefore you will get 0. Next one here also 0 into something. You will get 0. If you substitute in sin n pi x, sin 0 0. So the entire one is 0. Okay. So if you do the simplification, sin n pi, this term is nothing but equal to 0. Okay. So you left with the second term. This term is also 0. Okay. Therefore 2 by L into 2 by L into 2L into cos n pi minus 1 whole power n by n square pi square L square. N square pi square by L square. Therefore L will get cancelled. 2 into 2 4. 4 into minus 1 power n into L square by n square pi square. This is the an value. This is the an value. So next one bn value you have to find out. Bn is equal to 1 by L integral minus L to plus L f of x into sin n pi x by L dx. That is equal to 1 by L into integral minus L to L f of x is x square sin n pi x by L dx. So sin n pi x by L is a odd function. X square is even function. Even into odd is equal to odd. Odd between the limits minus L to L is 0. Therefore bn value you are getting 0. An is equal to this much and a naught is equal to this much. You substitute these three values in the Fourier expansion, you will get the final answer. This is about the basic problem. Okay. Today we are going to discuss one more problem, that is f of x is equal to 1 minus x square in the interval minus 1 to 1. So in the interval minus 1 to 1. So this is minus 1 0 and plus 1. So this one is 2L. So 2L is equal to how much here? 2. That implies L is equal to 1. So remember L is equal to 1. So first we have to find out A naught. A naught is equal to, what is the formula? 1 by L into integral minus L to L f of x dx. F of x into dx. L is equal to 1. Therefore integral minus 1 to 1 f of x is 1 minus x square into dx. F of that is nothing but 1 minus x square. If you come across with minus 1 to 1 or minus a to a or minus pi to pi, then you have to check this one whether it is an even or odd function. 1 minus x square is an even function. Therefore this you can write it as 2 integral 0 to 1 1 minus x square dx. Okay, that is nothing but 2 into integral of 1 is x square is x cube by 3 between the limits 0 to 1. That is equal to 2 into, if you substitute 1 upper limit 1 minus 1 by 3, that is equal to 3 minus 1 2, 2 by 3, 2 by 3 into 2 means you left with 4 by 3. So a naught value is equal to 4 by 3. Similarly, you have to find out an is equal to 1 by L integral minus L to L f of x into cos n pi x by L into dx, that is equal to L is equal to 1. Therefore, integral minus 1 to 1 f of x 1 minus x square cos n pi x, L is equal to 1. Therefore, cos n pi x you left with into dx. So if you integrate, if that is nothing but equal to 1 minus x square is an even function, cos n pi x is also an even function. Even into even is again an even function between the limits minus 1 to 1. This you can write it as 2 integral 0 to 1 1 minus x square into cos n pi x dx. Okay, that is nothing but 2 into integral of this much is nothing but 1 minus x square into cos n pi x integration min plus sin n pi x by n pi minus x square 1 minus x square differentiation is minus 2x. Next sin n pi x integration minus cos n pi x by n square pi square. Now it is the term plus into minus 2x, differentiation is minus 2 minus 2 into cos n pi x integration is sin n pi x by n cube pi cube between the limits 0 to 1. So that is nothing but equal to 2 into, if you substitute 1 1 minus 1 square 0 0 into something 0. Okay, minus into minus plus, plus into minus minus, therefore you will get minus. So 2 into 1 means 2. So cos n pi by n square pi square. Okay, minus into minus is plus, sin n pi you left with sin n pi. If you substitute in place of x1 you left with sin n pi. Sin n pi is equal to 0, therefore minus. Now you substitute the lower limit. If you substitute the lower limit sin 0 in the first term it is 0. Okay, so here if you substitute 0 2 into 0 0, therefore this product is also 0. Therefore 0 plus 0, here also the third term is also 0. Therefore what you left with is, so 2 into minus 2 minus 4 into cos n pi is minus 1 whole power n by n square pi square. This is the an value. Similarly you have to find out bn value. So bn value, how we can find? Bn is equal to 1 by L integral minus L to L f of x into sin n pi x by L dx. But 1 by L into integral minus L to L f of x is 1 minus x square into sin n pi x by L dx. So sin n pi x by L is which type of function? Odd function. 1 minus x square is even function. Even into odd. Even into odd you will get odd function. Odd function between the limits minus L to L is 0. Therefore what are the different values of the coefficients? A naught is equal to 4 by 3 and a n is equal to minus 4 into minus 1 power n by n square pi square and bn is equal to 0. You substitute these values in the Fourier expansion, you will get the final answer. Okay, today we are going to discuss half range Fourier series. Half range Fourier series. Previously we have discussed Fourier series in the interval minus pi to pi comma 0 to 2 pi. Okay, and we have discussed in the interval minus L to L comma 0 to 2L. So half range means nothing but 0 to pi interval. Here it is 0 to L interval. So then what are the formulas for half range Fourier series with the period or within the interval 0 to L? So what are the different formulas means A naught is equal to half range means always you have to remember 2 by something. Here 2 by L into 0 to L f of x dx. This is the A naught formula. Similarly, an formula. An is equal to 2 by L integral 0 to L f of x into cos n pi x by L dx. An formula. Similarly, Bn is equal to 2 by L integral 0 to L f of x into sin n pi x by L dx. Okay, so these are the basic formulas A for A naught, An and Bn. So only difference is here you come across with 2 by L. So in the previous it is the formulas you come across with the 1 by L. Here you come across with 2 by L. That is the only the difference. So in half range Fourier series you come across with another two words, half range cosine series. Half range cosine series. So half range cosine series means a naught value exist and an value exist and bn is equal to 0. Therefore the Fourier series f of x is nothing but sigma n is equal to 1 to infinity an cos n pi x by L plus a naught by 2. So similarly half range sine series. Half range sine series. So in half range sine series, which terms exist? Which terms exist means only the Bn term exists. Remaining A naught is equal to 0 and An is also 0. You have to consider. So then therefore the Fourier series is f of x is equal to a naught and an vanishes. Therefore f of x is equal to sigma n is equal to 1 to infinity bn sin n pi x by L. This is about the half range Fourier series. So in the half range Fourier series, first previously we have discussed in the interval minus pi to pi 0 to 2 pi. Okay, and we have discussed in the interval minus L to L and 0 to 2L. So half range means we will discuss in the interval 0 to pi. Here we will discuss in the interval 0 to L. Okay, so what are the formula for A naught here? 2 by L into integral 0 to L f of x dx. Similarly, an is equal to 2 by L into this much. Similarly, bn is equal to 2 by L into this much. So half range cosine series, that means only A naught comma an terms will exist and bn you have to consider as 0. Half range sine series, a naught an is equal to 0 and bn only exist. This is about the half range Fourier series with the in the interval 0 to L. In the interval 0 to L. So now we have to find out half range sine series and cosine series for f of x is equal to x in the interval 0 to L. Okay, now we are going to find out half range sine series for f of x is equal to x, half range sine series comma half range cosine series. So the interval is 0 to L. So first one, given function f of x is equal to x is the given function. Okay, next one, a half range sine series we will consider. Half range sine series. For half range sine series, a naught is equal to 0 and an also 0 and bn only exist, and the formula for bn is 2 by L integral 0 to L f of x into sin n pi x by L dx. So third step, so therefore bn is equal to 2 by L into integral 0 to L f of x. F of x means x. X sin n pi x by L dx. So this is nothing but 2 by L into 2 by L into x into integration of this one is minus cos n pi x by L by n pi by L minus x differentiation is 1 into integration of this one minus, as usual, cos integration is sin n pi x by L by n square pi square by L square between the limits 0 to L. So that is nothing but 2 by L into, so if you substitute L here, L by L is L will get cancelled, we left with cos n pi. So that means L into minus cos n pi. Cos n pi means minus 1 whole power n. Minus 1 whole power n by n pi. So this L numerator you will get minus L square. So minus into this minus into this minus. So you come across with plus. Plus into, if you substitute here in this place L sin n pi L by L sin n pi means 0, therefore you will get 0 minus, now we substitute the lower limit here, 0 into something 0 minus into minus plus, if you substitute here also you will get 0. So that is nothing but equal to, so minus 2 into L into minus 1 whole power n by n pi. So that is equal to 2L into minus 1 whole power n plus 1 by n pi. So this is the answer. For this is the value of the Bn. So how you got the Bn value means, this is the value of the Bn value. Bn is equal to 2L into minus 1 whole power n by n pi. So you substitute the a naught, a and bn values in the Fourier series. Therefore, f of x is equal to a naught by 2, a naught by 2. Only sine series means sigma n is equal to 1 to infinity bn sin n pi x by L. That is equal to f of x. F of x means x. X is equal to sigma n is equal to 1 to infinity bn 2L into minus 1 whole power n plus 1 by n pi into sin n pi x by L. So this is about the half range sine series. Similarly, for the same function, we have to find out the half range cosine series. Okay. So for the same problem, f of x is equal to x in the interval 0 to L, we have to find half range cosine series. Half range cosine series. So first step, f of x is equal to x he has given. So second step, half range cosine series is asking half range cosine series. Half range cosine series. A naught value, a formula. What is the formula? A naught value 2 by L into integral 0 to L into f of x dx. So that is nothing but equal to 2 by L into integral 0 to L f of x is x dx. That is equal to 2 by L into x square by 2 between the limit 0 to L. That is equal to 2 by L into L square by 2. 2 will get cancelled, we left with L. Therefore A naught is L. Next one, which value exists for cosine series an value? An is equal to again 2 by L integral 0 to L f of x into cos n pi x by L dx. That is equal to 2 by L into integral 0 to L f of x is x cos n pi x by L dx. That is equal to 2 by L into integration of this one means x into integral of cos means sin n pi x by L by n pi by L minus x differentiation is 1 into integration of this one minus cos n pi x by L by n square pi square by L square. So between the limits 0 to L. So that is equal to 2 by L into, if you substitute here L in sin n pi x, you are going to this one as sin n pi, that is nothing but 0. Therefore 0 minus into minus plus. If you substitute in place of x L sin cos n pi, cos n pi means minus 1 whole power n by n square pi square minus, if you substitute 0 in the first term you will get 0 minus into minus plus, cos 0 is 1, therefore you left with 1 by n square pi square and L square in the numerator. So if you simplify this one, 2 by L into n square pi square you take common, so what you left with is numerator you take L square also, therefore minus 1 whole power n minus 1, that is nothing but 2L by n square pi square into minus 1 whole power n minus 1. This is the an value. So you substitute the a bn is equal to, you will get 0 for cosine series. Substitute the an value this one and bn is equal to 0 and a naught is equal to L. So in the Fourier expansion, f of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n cos n pi x by L. You will get the final answer. Okay.